Okay, going to be covering a stand for either a laptop or a computer. I initially purchased a stand and used a laptop to drive my Crossfire XL. It didn't really work out very well as the machine was cutting. Of course, it's on rollers, and the thing would just be jumping back and forth, and this thing would just start shaking right to left, and it just didn't work out very well. So what I did was I just put everything on a roll-around cart that you can buy from Harbor Freight, and I put the keyboard and mouse in it, and you can see I can keep it a fair distance away from the table, so I'm not getting close to the smoke or anything. And the biggest thing of all that was productive for me was a use of a controller to control the positioning of the torch. Now, this software is called Keystrokes, and you can download it for free off the internet to control this remote device. And the good news is that the defaults that are in the software when you download it are already set up to drive this controller. So let's go take a look. I'm sure you've seen these before. You see you can control it. Now you can see how the table shakes. Well, and then when we had this stand on it, this thing just gyrated all over. So you may want to think about this approach to things. Okay, what we're going to cover now is how to align a sheet along either the X or Y axis. So in this case, we're going to align it in this direction. And so I use this thing here that I've built, two basically angle irons attached with a standard fastener. And you want to use a fastener, you don't want to use welds, because that will potentially warp the dimensions here. So anyway, so we want to align it in this direction, so we're going to put it in this orientation. And clamp it up, and so this thing is now 90 degrees to that, and so you just move your part up against it, and once it's up against it firmly, then you'll just take that off. And that's how that works. Okay, so now let's go ahead and see if we want to take the top of this part and orientate it this way. So we would just turn it 90 degrees, put the clamp on it, and then take this part and run it right up against it, and then we'll just release it, and there it is, sitting at 90 degrees. Okay, so the next thing we want to cover is, okay, how do we ground this part so we can cut it? Typically, the ground is some big clamp, and you put it on there, and if this is a small or light workpiece, the sheer weight of this plus the cable will sometimes twist it, lift it up, or whatever, and I find this to be completely unsatisfactory. So what I use is what I use on my welder. It's a magnetic attachment for the ground wire, and you just put on it and you turn it, and you've got a good ground. Now, what do you do if it's an aluminum part? Well, what you can do is take a metal washer and sandwich it between it, and there you go. Now you got a ground going through an aluminum part. However, you know, I think this is really unnecessary. What I've done is I've got a round that I have that's zinc plated, and I put it there, and I just come up through the stainless steel, because the stainless steel, the magnet won't stick to it. And then so here you have, so it grounds the stainless steel, and so the current will go from the stainless steel into the slats into the part, and I've never had a problem with that. You can buy this galvanizing compound from Ace, and you can just spray these slats, and it completely coats them with zinc, and they never rust. Best thing you ever buy. Now let's talk about the drain on this thing. Now you can see if the drain that comes with it, it's just got an open hole, and you know, the dross and everything else can fall up inside it. So what I did was I just took a high torque bolt, I think this is 3/8, cut it off, and I sprayed the zinc coating on it so it won't rust. And so I just put it in there, and so and when you cut, parts will fall on it, dross and everything else, but it won't go down into your drain. And then when you get ready to drain it, just reach down in there and just move the stuff away from it, open it up, and then you're ready to drain. Now, the drain that comes with the standard system is this. And the problem with this is that it's a 1/4 inch, not very much. And you really need a lot more. Now, what we just saw here was a 1/2 inch drain that I've installed. So let's come down and take a look at what that looks like. As you can see, it's much different. Now, the beauty of this arrangement is that I can use that to both fill and drain the tank in one easy operation. Okay, we're back here at the table, and we're going to go through the process that I use to get the water table all set up to be used. The first thing I do is come in and remove the plug, and I just set it up there in the rail. Okay, so then I'm going to come over to my hose bib, and I'm going to turn it on. And you can hear it spitting some air. And you can see it's filling the table at a fairly high rate. That's a 1/2 inch hole there. It only took a couple of minutes to actually fill this table, and then what you want to do is then put the plug back in, and now you're ready to cut with a clean set of water. Okay, we're back at the table, and we're going to be cutting a part off of this sheet. So we want to line this sheet, this edge, so it to be perpendicular to that gantry. So the first thing I'm going to do is bring the gantry about right there. I'm going to mount this device, which we talked about earlier. And this edge right here is perpendicular to that. So then I'm going to take this sheet and move it right up against it and make sure it's flat against it, which it is right there, and I'm just going to take it right off, and now it's aligned. What I have to do now is, for this part, the base point is going to be right here into the corner, and so we're going to move that. Using my remote device here. So that is perfect. Now, typically, you'd have to ground this plate, but we've got our grounding wire connected to the tray, which is conducting into the slats, which conducts into the metal. I've never had a problem. So we're going to go ahead and cut this part. Okay, we're here at the end of the day, and we're going to drain the tank. So we just reach down in where the plug is, make sure there's no dross around it, pick it up, and then set it aside. So we're all ready to drain. All we do is I just go over to my hose bib, unscrew the end of the hose, and you can see water's draining outside the hose. Follow it right back to the table, and it drains pretty fast. And I never close that hose bib valve. There's no need to. Okay, so at the end of the day, we've drained our tank. Took about 3 minutes, and clean all the dross out of it with a spatula. But I want to clean this thing, and I only do that every now and then, not that often. And so what I'm going to do is remove the water tray. Now it's not bolted down; it's just sitting on there. And you just sort of slide it out, and you can see the two cross beams there, so this thing won't fall through. Now you got the drain hardware on the bottom, so as this slides out, you've got to lift it up and slide it over. And so then you can just take it out and clean it all you want. And that's it. Okay, we're back out in the garage, and what we're going to be covering today is a splash guard and a spark guard. You know, when you run this machine, and it's just throwing sparks everywhere, fumes coming up, and water everywhere. And so, you know, it'd be nice to be able to keep all that off of torch height controller stuff, the lead screws in the back. You just don't want all these fumes condensating material on your stuff. And so the purpose of this guard is to prevent that from happening. Okay? So this is a rather complicated one, but it's really fairly easy to make. I'm going to take it off here real quick. And this is what it looks like. Now this is just a plate that I use to cover essentially what is the alignment hole. So when it's on there, I need to align the torch to it starting, I can see down through that area. Now, I just repurposed a clamp off a standard Langmuir torch holder, and it's held by 2 screws in the bottom. Now, you can see, looking at the bottom, it just collects a great deal of material, and it's that kind of material that you don't want, again, condensating on your torch height controller or any of your lead screws or any of your gantry surfaces. Okay, you can see this has got a plastic skirt on it. All it is some Nomex, but it's got 2 aluminum guards on the side, and the reason why they're there is because over time you'll get burned through along this area. The other areas are just fine. Now you can see it's not even on this one side, and the reason why is as the torch comes over and goes to its max thing, you know, it's going to bump up to that. So that's why we had to cut it short on this side, and that's why this comes up higher, because we don't want the fumes to come over and get right back into any of the torch height controller. I'll leave a reference to a DXF file for this top portion. Now, you don't have to run the skirts if you don't want to. It just gives you a little extra protection. So that's it. Okay, the last issue I want to talk about is the use of the Fusion 360 tool library to increase your efficiency and reduce cut errors. This is a cut chart for a Hypertherm 45, which is remarkably close to my Razor Weld 45. These charts are a good starting point. Over time, you will tweak these values to match your torch and cutting style and needs. You can download these charts off the Hypertherm website. The issue is then, where do you store these values? Langmuir has a YouTube video which takes you through the setup, cutting, and NC code generation process, and it's really good. They show how you enter a cutting machine, create a tool in the library, and then generate an NC program. However, they only enter one tool in your personal tool library. You have to manually enter all the cut chart info each time you create an NC file. This is time consuming and prone to error. A better approach is to enter a tool for each line in the cut chart. When you go to generate an NC file, you merely select the appropriate tool, and all the cut parameters that you find on the chart are automatically loaded into the setup, cutting, and NC files. Let's take a look at how this is done. Okay, we're in Fusion 360 now, and we're going to want to go in and take a look at our tool library. So we just select Tool Library, and I want to select my local library up here. Now you can see these are all the entries that I have made in my tool library off of those Hypertherm charts. And let me show you what this means. This is just the tool number, and that's automatically assigned. This is mild steel, 0.375 thickness, 45 amps, and it's going to be a quality cut. Now, I'm going to highlight that, and you're going to see over here on the right all the values that I've entered into that. You got your feed rate, cut height, pierce time, kerf width, and you got your speeds and feeds there. Now, once you do this, I'm going to show you here quickly as we generate an NC file that when you select this tool, all this information is automatically going to be downloaded where it needs to be downloaded. Now, anytime you have changes, you tweak the changes, you can come in here and change these values so you're never going to lose them. Okay, so now let's exit this. And let's take a look at the part. It happens to be the machine torch holder that was covered in a prior video. And we want to do a setup. So we're going to create a new setup. Okay. And we're going to select the machine. It already defaulted to the Langmuir. Okay. Model orientation, the box point. We're going to, I'm going to set the box point down here. Okay, and we're not going to do that. We're going to select that model right there. Okay, and then we're going to go over to post-process. And the program, we're going to call it a machine torch holder. Now, what we have here is program content. You can see where it's going to go right into your NC code. And what I put in here is I'm going to put in mild steel. It's going to be 0.125 thickness at 45 amps. Now, that will automatically go into my NC file. So when I pull it up on the Langmuir, it's going to show me that, and I can confirm, okay, I know what I'm cutting, I know how thick it has to be, and I know what the amperage I need to set on it, on the torch itself. Okay, so we're going to close that out. And so we have a setup. Now, what we want to do now is we'll go up and create a cutting tool. Get out of that. We'll just go up here. And it's going to be a 2D profile. Okay. And we're going to select the tool at this point. Okay. I'll go back in the library. And remember I said I wanted mild steel, 1/8 of an inch. I think I'd said 45 amps prior. It's really 40 amps. And I'm going to select that. And now you can see all these feed rates, they all changed. It was automatically downloaded into this software. I can come over and do a contour selection. I can say I want to select. Okay, so now we want to select the contours. And we got that selected. And we want this one here. And we've got it set to start the inside. And it looks like that's started on the inside. We want this one to start on the inside. That's started on the inside. We want this one to start on the inside. It's on the inside. We want this one to start on the inside. And that's on the inside. Now we want the next one to start on the outside. Now, I missed one here. Okay, so the inside cuts are most important, and we know that the right side gives you the most accurate. So we're going to have accurate holes, reduce minimum bevels in that. But on the outside, it's cutting on the left-hand side, which is going to cut bigger bevels, but we really don't care that much what's going on over there. Okay. And the finishing overlap, I'm just going to go with 0.1. And we'll just leave those, and now you can see the pierce clearance was automatically downloaded. So that's good. And now we got to do the entry position. So we'll just go ahead and select them. Okay, and so we've got the entry position selected. So we're good to go with that. And it's saying something there. One or more passes were discarded due to linking constraints. And what that is these holes here can't be cut with the current parameters. So we're going to go back and open that up again. And the lead-in distance, we're going to chop that down to 0.15. And everything was good. Okay. So we've seen now how all that information out of the tool library was downloaded into this. And now we're going to go through and set up or create our NC code or G code. Now again, all this information here was automatically downloaded out of our library and put in here. And so we're at this point, you know, we've got the name of the file, we've got what's going in the comments, everything is good to go. So we're just going to go ahead and post that. And the code was connected successfully. So you can see how it flows very easy when you use that tool library.